When Sandy Kidd goes out to the lock-up garage behind his house in Dundee, he is going into a world of his own. This place has been his prison for the past 4 years. Here he has spent every minute building a machine. A very special machine, a machine which he says will open up the universe.
What I really wanted to do, I suppose, was to create the means of powering a flying saucer, that somehow I could put a machine together, using gyros, in which all our energy could be properly harnessed to produce a lifting force, or thrust, which would be capable of driving some sort of craft through space.
Like most inventors, Sandy Kidd has paid a high price for his brainchild. It has cost him over £20,000 in lost wages alone. He has turned down better jobs. He has cut himself off from his family.
Well, I got so carried away with the thing that I just couldn't help myself. Looking back on it, I don't know how I really was able to subject my family to such sacrifice and hardship.
When I was courting Sandy, we used to go to the library when we went out. My girlfriend and her boyfriend, they always went to the dancing, the pictures, but Sandy always ended up in the library. This is where we spent most of the time reading up books on science fiction. He just wasn't like a normal person. He never was.
He has what it takes to make an inventor. The French word ingénieur, from which the word engineer is derived, means an ingenious one. And Sandy is ingenious.
The ingenuity referred to by Professor Laithwaite is built into this machine. Sandy Kidd claims it is unique because it can move on its own, requiring no contact with air, water, or solid surfaces, which brings us to flying saucers. Many people are convinced that flying saucers are real and are used to transport the inhabitants of outer space between stars and planets. If these magical machines are streaking across the heavens of the universe, then one thing is certain. Their technology is far advanced on anything we are using at the moment.
My machine should be able to deliver thrust over long periods of time, years if necessary. This would mean in space travel, very, very high speeds. The acceleration of the device could also be adjusted to create an effect within the device that would simulate the conditions of gravity that are on Earth's surface. And this would completely eliminate the problem of weightlessness. Mind you, the device has other uses than taking it to Mars in 34 hours. As it says in the patent papers, it is envisaged that the device has application on land, in or underwater, and in space, which means it can be used to power submarines and ships. You might even have the flying motor car.
His obsession with this dream sustained him through the years of hardship and sacrifice which it took to turn his idea into reality. He became almost a stranger to his grandchildren, but his wife Janet had learned early on she would have to live with someone who had an inventive mind.
He was always talking about space things, science books, Einstein, Asimov, all this type of thing. I wasn't really interested at that time. I've had to live with it so long that it's just grown on me, sort of thing.
Having married a man obsessed with travel and space, Janet Kidd and her family found themselves seeing less and less of Sandy as he fell under the spell of gyroscopes.
The thing was, I still had to carry on my full-time job with an oil company in Aberdeen, leaving home in Dundee before 6 in the morning and not getting home until 7 or 8 at night. It was actually in the train that the design of the machine finally came to me.
That was around 1982, by which time Sandy had risen to a responsible job in the North Sea oil industry, earning £25,000 a year. But when he arrived back in the evenings to his home in the suburbs of Dundee, he had to start work all over again.
He used to come home from Aberdeen at night, 7:30, he'd have his tea, in the door 5 minutes, out he went. He was outside till 2 in the mornings. I just used to go away to my bed and leave him. This went on for 4 years. With no social life, we gave up all our friends. 7 nights a week, all day Saturday, all day Sunday, it was spent in the garage. He didn't have time for anything else. To me, he was just obsessed by it.
Sandy's machine is all about gyros, a gyro being anything that spins round on the end of a rod. They behave dramatically when subjected to certain forces. This gyro weighs 50 pounds and has been fired up to rotate at over 2,000 revs a minute, so that Professor Laithwaite, an expert on the subject, can demonstrate the basic concept of Sandy's device.
Very little effort required, about as much as lifting an umbrella, and no centrifugal force. Now, of course, we have the problem of stopping it.
Professor Laithwaite studied Sandy's machine at the Imperial College of Science and Technology in London. Although known as an international authority on electrical engineering, the professor's know-how in gyroscopes has always led him to believe in the concept of a machine like this, a device based on gyroscopes which could produce a genuine lifting force. When he saw Sandy's invention create such an effect, congratulations were in order.
That is fantastic. There can't be any doubt. I mean, there you go, there's a whole object that goes up. By whatever means, it goes up.
Is he the first person to have done this?
No. Others have done it, and inevitably have modified their machines to try and make them better, stop them from working, and they've never been able to recreate the original machine. I've had several like this.
So how does Sandy Kidd stand then?
Well, he didn't make the mistake of meddling with his first machine. He kept it, so that when he made a second machine that didn't work, he said, what's the difference between this and my first machine? It's only the first machine made better. Then he realised he'd lost some of the flexibility through the rather loose engineering of the first machine, and was able to see what it was that was making it go. So then he's been able to make a better machine, knowing what it is that makes it go.
It was while serving as an RAF technician on Vulcan bombers in the early 60s that Sandy first became aware of the frightening energy a gyro can store up during rotation. One day, he had to remove a gyro from the navigation system of the aircraft.
I was walking backwards down a ladder, carrying it. Unknown to me, it was still running in its box. And the thing not much bigger than this. And as I reached the bottom of the ladder and turned round, the gyro reacted really violently and threw me on the back. I was really surprised at how much energy contained in a thing about this size. I'll never forget that experience.
10 years later, in 1974, when back in Civvy Street as a development engineer, he watched Professor Laithwaite demonstrate the powers of gyroscopes during a television lecture. What he saw that evening convinced him that somehow he could build a machine to harness a gyro's energy and put it to good use.
In deciding on the basic design of the machine, I knew I had to somehow mount 2 gyros within a structure at a critical angle, and by subjecting them to certain forces through rotation and movement, produce a lifting force through the action of the gyros.
The whole machine is designed to spin round like a top. When this happens, the gyroscopes want to fly off the end of their axles because they are being subjected to what is called centrifugal force. With the gyros themselves being driven at a very high speed in a certain direction, they react to the centrifugal force by swiveling upwards and taking the machine with them. Because of its design, it is only able to rise 2 inches off the bench. but the machine is capable of climbing to any height you want. The machine produces a thrust equal to 10 or 12 ounces, but the device itself weighs 7 pounds. To calculate this lift, therefore, Sandy devised a counterweight system consisting of a piece of string attached to the top of the machine, threaded round 2 overhead pulleys, then tied to an old vise loaded with 4-inch nails. When the machine lifts, Sandy gradually removes nails until the device starts to drop. The lift achieved is equal to the weight of the nails taken away. Now, this may all seem a bit crude, but such ingenuity is the stock and trade of the inventor.
One of the most important aspects of tackling such a complex project was making all the bits and pieces necessary and juggling them around until I got everything right. Well, being a toolmaker, I could make everything myself, and that was a real bonus. I could set my own pace and get things done my way, building one machine after another, getting the size of the gyros right, mounting them at the right angles, determining the rotational speed of both the device and the gyros, so that the two interacted to create the effect I was after.
Another of his many problems was deciding how he should drive his gyros. Finally, he chose a 6.5cc water-cooled model aeroplane engine and linked it up to the bottom of his machine. This engine can produce 1.25 horsepower at 16,000 revs a minute, transmitting that power to the gyros by a belt and pulley system. The machine itself is rotated by being connected up to an electric drill.
During my experiments, I burned out more electric motors than I cared to remember about. I was stealing motors out of any gadget I could put my hands on. Washing machines, lawnmowers and things like that. And doing all this, I was working with only a very basic grasp of mathematics and physics, which of course are very much involved in this type of engineering. In developing this machine, I've been plagued with setbacks, but having been a development engineer for years, I knew full well that you rarely get anything to work first time. It was very often a question of 2 steps forward and 3 steps back. At the weekend, I simply worked on the machine from morning till night. Towards the end, I dreaded having to go out to the garage. It became some sort of hell, but I just kept going.
I wasn't happy about it, because at the beginning I didn't believe him, but he persisted and carried on with it, and it was a failure so many times, and he promised to give it up, but he never did. He always gave it a couple of days, and out he went again. And this has gone on for months and months and months. I even got it in bed at night. He brought his books to bed, his papers to bed. He sat and drew pictures to me and tried to make me understand, but I never was able to understand it. I just had to live with it.
Although the machine worked for all the right reasons, using all the factors I had built into it, the forces within the device were operating in a different pattern from what I had imagined. In other words, I had created a machine which I did not fully understand at that point, but which was producing the desired effect. It was in trying to establish how these forces and other influences were actually behaving that really created bigger problems than I'd encountered before.
Most of the people that know Sandy believe in him. They know that he'll do it. He is quite a clever person, in my eyes. Well, I see a lot of things that don't mean I do try and help him as much as I can. Gardening, decoration, painting, every job about the house I have to do on my own. He just doesn't have time for any of that. He's too engrossed in his shed with his machine to do any of the things around the house. I've gone out and left him on his own. I've packed my bags quite a few times and been going to leave, but always came back.
During the cold winter months, it became a nightmare. All my family and social obligations went by the board, but the loneliness of working on my own and solitary confinement was the worst part of it all. After 18 months of building and rebuilding machines, I knew I'd come to the end of the road. If it didn't work now, I knew I had nowhere else to turn. I'll never forget that night. It was November the 21st, 1984, my 47th birthday. I went into the garage, started everything up, and then it happened. The machine lifted against the counterweight and stayed up. I could hardly believe it. It was a feeling of sheer joy and relief. I'd done it, cracked it.
Throughout this project, Sandy had worked alone without help from experts, not even from Professor Laithwaite, who had inspired him 10 years before on television. Now, in his hour of jubilation, he was the man Sandy wanted to give his news to first of all.
Well, I've watched this effect for 18 months now, and I couldn't figure out what it was. But I've now proved conclusively that from 0 to 1,000 revs, you're absolutely correct in what you said.
Sandy was so obviously genuine and so almost self-effacing with what he'd done. And of course it was gyroscopes, and I asked him a few questions such as are they offset gyroscopes with skewed axes and so on? And when he said that, I think, well, he's probably got the ingredient, and what does it do? And he said, well, it will lose some of its weight. And at this point you think, well, I can't afford not to see this, because I could be missing the big one. And when he was willing to bring it to me, as opposed to having me go up to the north of Scotland, well, of course he could come and see me. I think I've got nothing to lose. I think this man's the 1 in 100 who's different. You do get a sort of feel for it. You can spot the cranks a mile off.
Make the torque reaction of the gyro, overcome the centrifugal force, there's a point where these are free flying, and I expected the vertical motion. And it appears to work quite well on that.
Professor Laithwaite is himself a great visionary, a man who has constantly sought to push back the barriers of technology. In Sandy's machine, he saw the reflection of his own beliefs.
And this would work in outer space the same as it works on this bench. At the moment, the only method we know of travelling through space is by shoveling matter out of the back very fast in order to go forwards. And even science fiction writers, the people that did Star Wars, can do no better than talk about twin ion engines in which they squirt ions out of the back. They're still sending matter out one way in order to propel forwards in the shot and gun manner. Now, Sandy's machine, where it differs, is that he's produced a force by converting some angular momentum, which is easy to generate from things like nuclear submarines engines. And if you can convert angular momentum into linear momentum and propel yourself forwards without shoveling material out of the back, then you could go to the next galaxy on a teaspoonful of uranium.
The professor's experience with similar projects convinced him that Sandy's idea could only be developed with proper funding. This meant contacting someone who could match bright ideas with venture capital. Such a person was Martin Rose, a high-technology consultant who chose America as the place to test reaction to Sandy's machine. But why go to America?
Well, first of all, America is the land where dreams come true. You have a film star who's now a president, so anything's possible. And logically, therefore, it's a place where a reactionless motor, which sounds like an absurd idea, should be presented. There's no problem with gaining attention. There's no problem with funding an idea like that. The key issue is its application, the verification of that idea, and who verifies it. And if you're raising money to set up a company to drive an applications development team, you have to have the right people.
The Americans recommended university research, and that is what is now happening at Dundee, where Sandy has been awarded a consultancy. He is one of a university research team trying to establish how exactly the machine is producing its lifting force and whether that force can be made more powerful. This investigative work is being carried out under some security in a small lock-fast laboratory tucked away in the basement region of the university's engineering block. Working alongside the inventor is Dr. Ian Davidson, a lecturer in mechanical engineering who specialises in dynamics.
What we hope to do is a series of tests to try and see what the overall performance of the machine is. And these will be broken down basically into an initial set of tests which will measure the sort of overall properties, followed by a series of more complicated tests which might help to tell us something about what is happening inside the machine. The first test will be some overall force measurements on the lifting effect, and we've set up a force transducer, just a little lever, and on the lever we place what we call a strain gauge, which when it's stretched gives an electrical signal, and that we can display on a counter or an oscilloscope. It certainly is a very complicated phenomenon, so it will need a bit of time before we can actually pinpoint the actual mechanism which is creating this force. It's a difficult problem mathematically, and I would have thought that it's the sort of thing that we might well contemplate as a research project for a 3-year PhD or something of that nature.
As interesting as that?
I would say so, yes.
Because the machine generates such momentum, the university authorities have insisted that it can only be run behind a strong metal guard. This caution over the safety aspect of the device is matched by Dr. Davidson's own reserve when he is asked if Sandy's machine will provide mankind with a new source of energy.
I would prefer to answer that question some considerable time later when we have a much clearer idea of what the machine actually does and the extent of this phenomenon. At the moment, it is an interesting phenomenon. Let's examine it and see what might come from it.
One man at Dundee University who harboured no doubts about Sandy's machine was Dr. Bill Ferrier, a senior physicist. Like Professor Laithwaite, he was deeply impressed with both man and machine.
Bill and I became great friends through this machine, and he often came around at night, spent many hours discussing gyroscopic theory.
The two of them would sit discussing the machine and what it could do, what it could be used for. They'd work out formulas, there'd be papers lying on the coffee table all over the settee. Eventually I gave up and went away through to my bed. But the pair of them still sat here all hours discussing the machine.
Bill was working on a mathematical formula to explain away the workings of the device, and he informed me that he was getting pretty close to putting some answers together. Unfortunately, Bill died in late summer 1986, and since then nobody's been able to reproduce his work. But Bill did leave this written endorsement of my work.
There is no doubt that the machine does produce vertical lift. I am fully satisfied that this device needs further research and development. I have expressed myself willing to help Mr. Kidd, whose engineering ability is beyond question and for whom I have now the greatest respect. I do not as yet understand why this device works, but it does work. The technological possibilities of such a device are enormous. Its commercial exploitation must be worth millions.
I have not seen anything of this type before. I find it interesting, and as a dynamicist, I would very much like to be able to track down what is actually happening.
It may take you years, but if you know you're going to get there, and you've got the patience and the perseverance, you've got all the ingredients you need.
My prediction is eventually I will win through. I've got this far. It was a struggle. I have got to assume that having got into a university establishment, that I'm winning. It's taken time, but I'm getting there. And I have got to allow the academic chappies to make up their own mind at the end of the day. Eventually, they've got to come round to the same conclusion as me.
Is it going to change the world?
I think it will, if it's allowed.
Immanuel Velikovsky, the famous Russian scientist and writer, put it this way: "What I want to impress upon you is that science today, as in the days of Newton, lies before us as a great uncharted ocean, and we have not yet sailed very far from the coast of ignorance."